Python data types, experiment 3. In this session, we are going to discuss more in detail about the float data type. Now, before we get into the discussion of float data type, in my last video session, I was briefing about the number systems and how Python deals with number systems. I forgot to give you a chance to understand what type are those number systems fall under. Even though I mentioned that it is of a family called integer, but we haven't visualized whether those variables of decimal, binary and octal fall under integer or not. So to summarize on that, I'm just using this demo for understanding that these binary, octal, hexadecimal all fall under the family of integer. So how do we express a variable as a specific type or not? With the help of a special function called type. I think we already discussed about this function in earlier videos as well. So by now you knew how to use type function. Now when I mention the type for these x, y, z and e variables, you will not get to know whether it's a binary or octal, but then you will get to know what type they fall under. So let's execute this. You can closely watch the result that it says x, y, z and e is all falling under the category called int. So it's a confirmation that all these number system types of representation are falling under the type called integer. Hope this gives you a clarity, and visually we are understanding, yes, all these number systems are of type integer. Great. Now we'll quickly move on to the float. Now, how float works means how the float data type works. Float data type works with a decimal point. So we go ahead and declare a variable called f equals 3.14. This 3.14 represents a floating value. I believe you all knew how a floating value would look like. So this is a representation of a float value, a pretty simple notation. Now, while you print this f, you notice that it exactly captures the floating value. But how do we confirm that it's a floating value? Again, we are going to use the function called type in order to understand that this 3.14 falls under the category called float. The result is there. You can easily notice that this 3.4 value, which is referred by the variable called f, is pointing to a data type called float. And float falls under what family? It falls under the numeric family, which we have already discussed in the beginning of the session. So here, when it comes to the float representation, we can manipulate the float representation in many other formats as well. So let's take some example of that so that we will get some more understanding of how Python deals with float. Okay, so now let's try to print 4.2. Okay, this prints 4.2. Now see, ideally I'm not using any variable or I'm not using any print function in order to print it. That's the power of the interpreter that we are working with. So this is a Jupyter notebook, and it internally has the functionality of it, expressing the numbers, expressing the manipulative code like addition, subtractions. All these are feasible in a straightforward references of those values. You need not store them in some variable and try to print them out. Now coming to this 4.2, which is a reference of float, the same way we can even print 0.4, and that exactly treats as 0.4. And why not? We can even try out saying 4 dot means 4 point, which will be considered as 4.0. So you either say 4 point, it says 4.0, or you say 0.4, it takes it as 0.4. So these are the ways where we can actually manipulate the floating values in Python, but this is not the limit. We can go even further to understand what are the other ways and other formats that we can represent float in Python. Okay, now let's quickly understand another pattern of floating values. I'm trying to represent 0.4 exponent with a value of let's say 4. Now when I say exponent of 4, you know what exponent does. Okay, it powers up the value by 10. So 0.4, 10 to the power 4. Now in this case, this representation is again considered to be a floating representation. To know that it is of float type, we can again use a type of that particular value that you are trying out with. Will capture that it is a float type. So the consideration here is float can be represented in many formats. Still Python deals with it, and the notation that we use in order to generate a long number is with e. That e represents an exponent, and you can power up the exponent with the number that you provide there. We will see one more demo for that pattern of exponents. Let's say I have something called 4.2 exponent. Now it's 4.2 exponent minus 4. Okay, so when I say minus 4, you see the result. It's like 0.00042. But if I give it with exponent of 4, it's going to be 42000.4. So where the decimal place matters. Okay, the decimal point, the value post the decimal point matters. So whether it is a negative decimal values or is that a positive decimal value. Now the exponent works on the positive value, and the same exponent is going to be operated on top of the negative value of powering, so that the result will change in this order. So this is also feasible in Python. It relates exactly how to deal with the positive and the negative exponent of the floating values in it. The next understanding is, what is the maximum value that it can go with when it comes to the floating representations? Let's take another example. Here, if you look at it, I'm trying to print 1.79 exponent 308. Oh, that looks to be a huge number, right? Because exponent of 308 is nothing but a representation of this. So let's say 1.7, okay, 9 into 10 to the power of 308. So 1.79 into 10 to the power of 308. This is something unimaginable numbers, like it looks like that, but then you will have the representation for that. And here in Python, we represent that with 1.79 exponent of 308. Now see what the result is all about. So you exactly get that. It's a positive exponent, and you get this output. But the same, if I go with the change of 8, 7, 9 is increased with one more number, and it is represented as 1.8 exponent of 308. And if I print this, it is represented as inf, meaning as this is a string representation, and this is unable to cater the length of the floating values, because the maximum number that it can take, the maximum number that it can withhold is less than of 1.8 into 10 to the power of 308. So you can stop till 1.79 into 10 to the power of 308, but you can't go with 1.8 into 10 to the power of 308. So from there on, any number of exponent interpretation that you go with, it just comes up with an information of a string which doesn't cater that number, because the maximum number that it can cater in the floating manipulation is 1.79 into 10 to the power 308.